Dear students, my name is Raju, working as a lecturer in mathematics, KLEPU College. I am going to discuss few concepts in the topic probability. So before entering into the MCQs, let's discuss few formulas in detail. Very simple. So probability, it's a very interesting topic. So this topic is used to find the probability of some events, certain events. They are simple events, conditional events, compound events. Just I will explain one by one. This is classical definition of probability. Probability of any certain event is number of favorable cases by total number of cases in the experiment. This is conditional event. Probability of this conditional event happening of E after happening of F, that is probability of E intersection F divided by probability of F. This denominator probability that does not equal to 0, non-zero value. Again, probability of this compound event A intersection B is product of probabilities of A and probability of B given A. This is called multiplication theorem. This is applicable whenever A and B both are dependent events. What is the meaning of dependent events? Dependent events means in any random experiment, out of two events, happening of one event affecting other event. These two events are called depending events. For example, in a pack of 52 cards, drawing two cards successively without replacement. Out of 52 cards, I will select two cards. After selecting two cards without replacement, I will select two more cards. These two events are called dependent events. If any problem is involving directly or indirectly without replacement, you should understand that both the events are dependent events. Next, probability of A intersection B is product of probability of A and probability of B. This is also multiplication theorem. This is applicable whenever A and B both are independent events. Independent events means in any random experiment, happening of one event does not affect the another event. For example, selecting two cards successively with replacement, selecting two more cards. With replacement means the number of cards in the pack are unaffected. So happening of one event does not affect the other event. Selecting two cards with replacement, selecting two more cards. These two events are called independent events. In any problem, if it is directly or indirectly involving the word without replacement or with replacement, if it is involving with replacement, independent events, without replacement, dependent events. Here, this multiplication theorem is applicable for when A and B both are independent events. Next, extended form of this dependent events multiplication theorem. This can be extended up to more than two events. For example, in a random experiment, if probability of happening of A and B and C, probability of this event when A, B, C are dependent events, its probability is product of probability of A, probability of B given A and probability of C given A intersection B. If the problem is involving more than 3, for example for n events, E1, E2, E3, E4, so on to En, all these are dependent events, then multiplication theorem is applicable. Product of probability of E1, probability of E2 given E1, into probability of E3 given E1 intersection E2, product of probability of E4 given E1 intersection E2 intersection E3, so on to. In this way, you can extend this dependent events formula up to any number of events. Next, addition theorem. If the event happening of either A or B or at least one, that is represented by A union B, happening of either A or B or at least one, the meanings are same. Its set theory notation A union B. Probability of A union B is sum of probabilities of A and probability of B minus probability of A intersection B. The same addition theorem, whenever A and B both are mutually exclusive events, then A intersection B does not exist. In this case, probability of A intersection B will be 0. Then probability of A union B addition theorem becomes sum of probabilities of A and B. Two more extended forms of this addition theorem. Whenever the problem involving the event happening of A and not happening of B second event, set theory notation representation A intersection B bar. Probability of this event is probability of A minus probability of A intersection B. Similarly, not happening of A and happening of B, for this event probability is probability of B minus probability of A intersection B. Now, based on these concepts, classical definition, conditional probability, multiplication theorem, addition theorem, we'll discuss few interesting MCQs which were asked in the previous examination of CET. Let's start one by one. Dear students, look at this first problem. What is the probability for a leap year will have 53 Sundays? Options are: first option 1 by 7, second option 2 by 7, third option 5 by 7, fourth option 6 by 7. First, you identify what is the event. Here the event is getting 53 Sundays. Here available a leap year. A leap year means a leap year will have 366 days. This 366 days includes 364 days plus 2 days. Again, these 364 days means 52 weeks. In this 52 weeks, we can have 52 Sundays. We need to have 53 Sundays. So we already got 52 Sundays in this 52 weeks. Now we have to find the probability for getting one Sunday from the available 2 days. Now I will write what are the available these two consecutive days. These two consecutive days can be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, last one, Saturday, Sunday. So these are possible 2 consecutive days. I will take it as sample space yes. Means total number of cases available 1, 2, 3, 4, 5, 6, 7. N of S is 7. Now, this one Sunday, I will take it as an event. E be the event getting one Sunday. Getting one Sunday. For this event, get what are the favorable cases from this sample space. In this, out of 7 cases, how many cases are showing exactly getting one Sunday? They are this case Sunday, Monday, next Saturday, Sunday. These 2 cases are favorable for this event E. Therefore, favorable cases for this event E is 2. Now, using classical definition of probability of that event E is N of E by N of S. N of E is 2, N of S is 7. Therefore, the second option 2 by 7 is correct option. Dear students, look at this next problem. If n coins are tossed simultaneously, the probability of getting head an odd number of times. Options are option A 1 by 2 power n, option B 1 by 3, option C 1 by 2, option D 1 by 2 power n minus 1. So here, identify what is the event. The event is getting head an odd number of times. So here, I am writing what is N of S. N of S means total number of cases in this experiment. So here we are using a coin. A coin has 2 faces. Total number of coins we are using n number of coins. Therefore, total number of cases are 2 power n. Now I will write what is the event. The event is getting head odd number of times. Getting head odd number of times means I can have 1 head or 3 heads or 5 heads, so on to any number of odd number heads. So this is for this favorable cases n of E. When n coins are tossing, getting 1 head is NC1. R stands for plus. When n coins are tossing, getting 3 heads NC3. R stands for again plus. N coins are tossing, getting 5 heads plus, so on to. This is sum of all binomial coefficients of even terms. This equal to, this sum is 2 power n minus 1. Now, by the classical definition of probability, n of E by n of S. This is n of E is 2 power n minus 1 divided by n of S 2 power n. This is 2 power n into 1 by 2 divided by 2 power n. This is 1 by 2. Therefore, C 1 by 2 is the correct option. Look at this next problem. If 2 dice are thrown, then the probability that sum of the numbers which comes up on the dice to be more than 5. Option A 5 by 18, option B 5 by 36, option C 13 by 18, option D 1 by 6. Here total number of cases. You are rolling 2 dice. When 2 dice are rolling, each die number of faces are 6, number of dice you are rolling 2, therefore n of s is 36. Here what is the event? E be the event getting sum on the 2 dice is greater than 5, more than 5. To get this favorable cases for this event, total number of favorable cases to get sum of 2 dice dots are greater than 5. For this we have one shortcut technique to find how many cases are there that are favorable to get sum as greater than 5. The shortcut technique is, look here I will write the shortcut, sum of the dots, here number of cases, sum of the dots. When 2 dice are rolling, minimum sum will be 2, maximum will be 12. So getting sum as 2, number of cases will be 1. They are 1, 1. Sum is 3. Such cases will be 2. Getting sum 4, such cases will be 3. Getting sum as 5, such cases 4. Similarly, 6, 7, 8, 9, 10, 11, 12. So here 4 cases, again 5 cases, again 6 cases. From here to here, write in ascending order. Again from here to here, descending order. Cases will be 5, 4, 3, 2. Getting sum as 12, only one case will be there. So using this shortcut, look here. Sum is greater than 5 means that sum can be either 6 or 7 or so on to up to 12. How many such cases will be there? Sum is getting 6. Look at this. Sum is getting 6. Such cases will be 5. Sum is getting 7. Such cases will be 6. So on to sum is getting up to 12. So we will have 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. This is n of e is equal to sum of all these cases 26. Now probability of this event is n of e by n of s. This is 26 by 36. This is 13 by 18. So 13 by 18, the option C is correct option. Look at this next problem. The probability of getting a number between 1 and 100 divisible by 1 and itself. So this is the problem. Option A 1 by 4, option B 1 by 2, option C 3 by 4, option D 25 by 98. Here n of s. N of s means total number of available numbers. Here they have mentioned that numbers between 1 and 100 means there are 98 numbers. Selecting one number 98C1, this is 98. Now I am writing the event E. E be the event of selected number divisible by 1 and itself, means getting a prime number. Between 1 to 100, how many prime numbers will be there? Between 1 to 100, there are 25 prime numbers will be there. So, by classical definition of probability, number of favorable cases by total number of cases. Here, number of favorable cases 25, total number of cases 98. Therefore, option D is correct option. Look at this next problem. If 5 cards are drawn from a pack, the probability of selecting 4 of them will have the same face value. Option A, 13C1 into 48C1 by 52C5. Option B, 13C4 into 39C1 by 52C5. Option C, 13C1 into 39C4 by 52C5. Option D, 13C1 by 52C5. Dear students, here they have mentioned what is the probability for selecting 4 of them will have same face value, means here I am writing the event. The event E is in the selected 5 cards, out of them 4 will have same face value and remaining one is other card. Means what is the meaning of same face value? Same face value. In a pack of 52 cards, 26 red cards will be there, 26 black cards will be there. Again in the 26 red cards, 13 set of cards hearts, 13 set of cards diamonds. Again in 26 black cards, 13 clubs, 13 spades. These are set of colored cards, red cards, black cards. 13 symboled cards, hearts, 13 hearts, 13 diamonds, 13 clubs, 13 spades. But here the thing is having same face value. In pack of 52 cards, how many cards, set of cards will be there, sets will be there which are having same face value. For this, look at this concept. In this 52 cards, there are 2 colors, 26 red colors, 26 black colors. Out of this 26 red cards again, 13 hearts, 13 diamonds. Again 26, 13 clubs, 13 spades. Here all these 13 set of hearts will be numbered cards 2, 3, 4, so on to Jockey, Queen, King, Ace. Similarly 13 diamonds 2, 3, 4, so on to A. 13 clubs 2, 3, so on to A. 13 spades 2, 3, so on to A. Here first I will select one set from this set of, look here, having same face value, one set 2, 2, 2, 2. Second set all are having 3. Third set all are having 4. Like that all set of cards having same face value A. Here in this 52 cards, 1, 2, 3, so on to 13 sets are there which are having same face value. So here for this event to write favorable cases n of A, we have to select 5 cards in total. Out of these 4 are of same face value. For this, out of 13 sets, I will select one set. Selecting one set means selecting 4 cards of same face value. After that, remaining one card which is other than this same face value means, for example, I would have taken the set of having same face value 3. So out of 52 cards, I have selected one set having same face value. There are 4 in number. 52 minus 4, then 48 cards will be there. 48 cards which are not of the same face value. From these 48 cards, I will select one card. So here selecting one set means, from 13 sets selecting one set means I have selected 4 cards are of same face value. Remaining one card, that is other card, that is from the other than this set. Other than this set means from 52 I have subtracted those 4 cards which are having same face value. They are 48 in number. From 48 cards selecting one. Here selecting one set means what? Selecting 4 cards, here 1 cards. Total cards are 5. I have selected 5. 4 are of same face value, 1 is of other card. Now, n of s. What is n of s? N of s is total 52 cards are available. From 52 cards, selecting total cards 5. So, by definition of classical definition of probability, n of e by n of s. N of a is 13c1 into 48c1 divided by 52c5. So this is the option A. Look at the next problem. 2 cards are drawn from a pack. The probability that one of them is a club and other one is not a club. Dear students, for this problem, total number of outcomes means 52 cards are there. From this 52 cards, selecting total 2 cards. This is n of s, 52c2. Here the event is selecting. In the selecting 2 cards, we have to selecting 2 cards. In these 2 cards, one is club and other one is non-club. Now, I am calculating favorable cases. Selecting one club means in pack of 52 cards, how many clubs are there? 13 clubs. From 13 clubs, selecting one club and stands for multiplication. Second one is non-club. Non-club means from pack of 52 cards, if you subtract 13 clubs, remaining 39 which are non-clubs. From these non-clubs, I am selecting one card. This is favorable cases. Now, probability of this event is 13c1 into 39c1 divided by 52c2. This is 13 into 39 divided by 52c2, 52 into 51 by 2. On simplification, you will get 13 by 34. Therefore, D is the correct option. Next problem, if a number x is selected from 1 to 100, then the probability for x plus 100 by x is greater than 29 is options A 41 by 50, option B 47 by 50, option C 39 by 50, option D 37 by 50. Dear students, here total number of numbers given 100. From given 100 numbers, selecting a number, x means selecting one number, therefore total number of outcomes are 100 C1, this is 100. Now, here the event E is given x plus 100 by x greater than 29. To get the possible values for E, so I am solving this inequation. This is x square plus 100 by x greater than 29. This implies x square minus 29x plus 100 greater than 0. For this factorization, x square minus 25x minus 4x plus 100 greater than 0. This is x into x minus 25 minus 4 into x minus 25 greater than 0 means x minus 4 into x minus 25 greater than 0. For this solution, x is less than 4 or x is greater than 25 means possible values for x means the set A, x is less than 4 means it can be 1, 2, 3. X is greater than 25 means from 25 to 100. So here n of E, total number of favorable cases from 25 to 100, 75 will be there, 76, 77, 78. Total number of cases are 78. From the 78 cases numbers, selecting one number x, this is 78. Now, probability of success, probability of E is n of E 78 by n of S 100. This is 39 by 50. Therefore, C is correct option.